Hi and welcome to Squiz.com, the connected marketplace. Today I'll be showing you the newest changes we've made to the Squiz.com connector software in the 1.24 release. The Squiz.com connector is a free piece of software developed by us that allows the business to connect any of its business systems, databases, spreadsheets or files storing data into the Squiz.com and Todex platforms, allowing businesses to save and make more money by automating data management and data transfer between its systems and other supplier and customer systems. Now you understand what the connector can do, let's look at the changes we've made to the connector in the 1.24 release. This release adds the new capability to manage make model data within the connector's data sets feature. Make model is a common searching data structure that allows customers to find products when products are a part of a greater object, such as an automotive vehicle, printer, computer, white goods, bicycles, or any other things that contain collections of components. We call these models. Within the dataset, a list of models, also known as makers or manufacturers, can be defined, as well as a list of models and model data that each maker creates. And additionally, products can be assigned to each model. Managing and merging make model data within a dataset can make it quicker and easier for businesses to set up make model data, allowing customers to quickly find and purchase products they know based on using make model search features available in the Squiz.com and Todex platforms. The Squiz.com connects the dataset feature also gets a new ribbon bar to make it easier to navigate between the different sets of data that can be managed within the dataset window. The datasets window also allows the product data and model data to be opened up in their own separate windows, allowing product data to be more quickly be found and copy across to the other data types using side-by-side windows. This release adds a new capability of integrating the connector with the PARtsDB online platform. PARtsDB manages make model data across the automotive industry, allowing automotive businesses to synchronize their products into the existing list of cars and trucks that PARtsDB keep up to date. This can take the burden away from businesses having to set up automotive make model data themselves, saving hundreds of thousands of dollars in data labor each year. We've released an add-on connector that can pull in the make model and category tree data from PARtsDB, then store and translate it into the Open e-commerce standards documents using the connector's generic adapter preset. The connector can then send the make model data across into a dataset, as well as into the Squiz.com and Todex platforms. This all allows for seamless automated data synchronization of make model data for businesses selling commodity products into the automotive industry online. The 1.24 connector release adds the capability of integrating the connector with the Readysell enterprise resource planning system. This allows organizations using Readysell to seamlessly have their inventory, pricing, customer data synchronized to the Squiz.com and Todex hosted websites, as well as instantly push back sales orders into Readysell's system. It also allows real-time customer account inquiries to be performed, including invoice, payments, credits, and transaction searching. The preset factors in Readysell's advanced pricing data structures and can be set up quickly by loading in the Readysell preset that's included out of the box with the connector's generic adapter. This also allows for further customization of a Readysell integration to occur once the preset has been deployed. For the connector's JSON, XML, CSV query browser and the generic adapter's associated data source type, we've added a new round field function, as well as improved the replace function to support regular expressions. These functions make it easier to manipulate data coming from web service-based systems, APIs, and files when certain textual data needs to be replaced with other data, as well as when numeric data needs to be rounded up or down to a certain number of decimal places. These functions add to a long list of tools that helps integration specialists and data analysts translate and manipulate data being passed from one system to another when using the connector software. Lastly, within the connector's micronet distribution adapter, we've added additional capabilities to pull out quantity break product pricing from the micronet distribution system, and those quantity break prices have been set up within that system's advanced category matrix discounts pricing feature. This feature allows categories of products to have pricing discounts applied to a broad range of target customers. The connector's adapter now factors in this advanced pricing structure when its product and customer account pricing data export sends all pricing data to the Squiz.com and Todex platforms. Now, if that's not enough, included in this release there are a number of other small improvements and bug fixes that can be read by going to the connector's documentation center, and within there, scrolling down to the version history page contains more details on what changes have been made in this release cycle. And always feel free to subscribe to the Squiz.com YouTube channel to stay informed when we release new great functionality into the connector. But now let's get into the detail of the latest changes made to the connector. Within the 1.24 connector release, we've added a new capability of managing make model data that is stored within the datasets feature. If you're not already aware, in the 1.22 connector release, we added the capability for the connector to export make model data to the Squiz.com and Totex e-commerce platforms, and now we're allowing the ability to manage make model data from within the connector itself. If you're not already aware, make model allows customers to be able to find products when those products are components that belong to a complete model that is created by a manufacturer. So typically a user would choose from a list of different manufacturers that create completed objects or models. So in this case, we might be looking at printer cartridges, and then from there they can then select the printer, which they may need to get more inks for. After selecting the make and the model of their printer, they can then find the printer cartridges that apply to their printer. So make model data structures are used in many different industries. Typically manufacturers have interchangeable commodity products that can be changed for their outputted goods. So in this example, we could be looking at printer related stuff, but we could easily be looking at motorcycles and all the different manufacturers that produce motorcycles for the many different years and models that motorcycles exist for. It could be for cars, if we were selling products within the automotive industry. For cars, it could be for computers, it could be used for phones and tablets, among many other things that can be manufactured in the world and that have interchangeable or replaceable parts. So if we open up the connector and click on the datasets feature, for any datasets that have been created, or if you want to create a new dataset, once we click on the view button to view a dataset, within that there is now a button called make models that allows us to see 4 different tabs that enable setting up data structures to support make model searching. So the first thing we have is this tab called makers. Makers may be known as manufacturers or makes. And this is where we need to define all the lists of the makers that may contain models that our products need to be assigned to. So already I've created a number of makers that appear here. We have the key maker ID, so every maker that is listed in this list needs to have a unique value set. So in this case, we decided to use numbers as well as a suffix containing the manufacturer's name. So if we were looking at printers, for example, we might support another printer manufacturer, so that may be Canon. We can give that maker a code that it can be more easily found by, but it could be any kind of code. You could have it 20 characters or 5 characters in length. It's up to you to do that. The maker search code just allows for cleaner looking URLs where you'd use that data, and you'd want to give the name of the maker. So this is Canon. We can group our makers into different classes. For example, if we're looking at motorcycles, you can see that we may create a most popular class and we might create an others class. So we've created one for cars and motorcycles, electronics and printers. Up to you to define your own classes. We can then just choose how those manufacturers are ordered. So we could, if we've got cars, we might want Holden to become first before Toyota within a list. So that's where we've changed the ordering there. We can give the name, the official name of that organization. The organization of Canon may be actually something much longer. So it might be Canon Inc., for example. We can put in the authority number, and so that may be the Australian business number for Canon Inc., and that might be Canon Australia. And then we can find that using the ABR lookup. We can also set the number types. So within the e-commerce standards documents, we have different numbers that can be set for the different authorities in the different countries. So 1 corresponds to Australia, 2 is the Australian company number, whereas 3 is Great Britain, 4 is the New Zealand business number, and 5 is United States employer identification number, and so on. And no doubt this list would extend further. So if we put the value 1 in here, that's what that authority number type is. Now in the established state, we can set when that company is established. If we're looking at Canon, they may be established in the mid-20th century, and we can set whether or not these manufacturers are active and should be exported out, or if they should not be. And if that is updated, tells us if we're doing imports into the dataset, whether or not those records were changed. We've also got the created and last modified date times to show us when those values have updated. Anytime you change a value here, you'll see the numbers change corresponding up in those fields as well. Our objective here is to find the list of manufacturers that create models for which we need to assign our products to. So if we're going back to our example for printers, we may have some ink cartridges that we sell for Epson printers. So in that case, we then need to define the models of those printers that exist for Epson. So that's where we get into the models tab. We need to define the list of models that Epson then sell. So already I've created a couple examples here where we've got 2 Epson printers, the Epson XP220 and as well as Epson Workforce WF2630. And we now may want to support another Epson model that we can assign our ink cartridges that we sell for those printers. So we need to firstly assign our model to a maker. So we need to use the unique identifier of that maker. So in this case, we're using Epson. So we place that in there, and once that's placed, we'll then try to find the associated record for that manufacturer. Now we need to give each model a unique identifier, so that way the systems that they get imported into know that this is the data that needs to be updated. So you could use any kind of unique identifying system. You could use numbers like we're using here, or you could use names and numbers if you wanted to. It's up to you how you set that, but every model listed here has to be, this value has to be unique. For a model code, we can set what is the code that humans may know this model by. So if we're looking at the Epson workforce, the model code may be this WF2650. It may have a subcode for it as well. If it is, you might have two models that have the same code but have different subcodes. So there could be AB and this one could be DF, like we see with these cars that we've got here. The search code is for URLs, and it's also maybe used for searches as well. So we're using the same name, but we're just using delimiters. We've got the group class, like similar to makes. We can then group our models together based on different classes. So we're talking about printers here, so it'd make natural sense to give them a group class of printer. Now the release date is the date when that model was officially released out into the market. That's the important date here. So this printer may have been created in 2015. And date is important for when you want users to be able to filter the models based on date. So in the automotive industry, cars may be known for the date that they were released, or the year that they first were introduced, as much as the actual name of the model itself. And the creator date is when that model first began being created by that manufacturer. So that may be a date before the official release date happened. So Epson may have created this printer or started working on this printer in 2013, but they didn't actually release it, and it's not known by that date, but the release date there. Similar to makes, you can set the is active and is update fields, and any time that the models are changed, the last modified date time will update, as well as you can set any notes against these models. So our job if we're selling ink cartridges would be to find all the models that our ink cartridges are associated to, and we might wish to import that data into the dataset itself, as opposed to doing this on a one-by-one basis. Now for each model, you can define then attributes, and that is additional data associated with those models. In our example here, we're looking at Apple iPhones. We need to define some attributes, and earlier releases also talk about how to set up attributes. Basically, we can set up unlimited amount of fields that contains additional data about our models. So I've created a profile here called phone attributes, and these are the details of the phone, and then under the attributes tab, we can then set the fields that we can place data into for our models. So for our phones here, we may define a field that contains the storage size of a phone as well as the color options, and then we may wish to also contain additional data about the phone. Our customers may want to know the warranty length, so we could create an attribute for that, and then we could define that the values for that warranty limit field can only be numbers. So when we go back into our model and we click on the Find Reload button, we will see that for phone attributes, so if we look at our Apple iPhone models here, the warranty for that may be 2 years. So we can put in the values there. Our gigabyte storage might be, you can get those phones in 64 gigabytes as well as 128. The color options for this phone, maybe it comes in white, black, and metal. Now you've got a choice here where you can have these values appear in one field, but the better approach is to click the insert button, and that will duplicate this, and then we can set multiple values against the one field. So if I click that again, this is a much better way, or a more normalized way to set up data, so that in the color options, that will then list out all the colors that in the associated platforms that this gets assigned against. So that's an example how we can set more information about models. That's what the attribute values covers. So if we're looking at printers, some of the information that we may care about when dealing with printers is maybe the size of the printers, or the functions that printer supports. Maybe it supports only printing, or maybe a device that allows for scanning as well as copying. So when we could then create another attribute profile, which is specific for printer specifications, any kind of extra information that you want to put against the model, that's where you can do this within the model attribute values here. And you can also got these search filters. So in our example for where we were dealing with phones, we may only want to look at the attributes that are associated to phones. So we could then do a filter. We're limited to seeing only the attribute columns that are associated with that given profile, which makes it easier for us to then set the values against those different models. You can also filter down what models appear in this list. So at the moment, it's getting all the models that appear in the dataset, but we may only care about any models that have the name Apple in its name. So then we're only dealing with Apple-based models that we want to assign attributes to. So that's what those filters there. There's a lot of different options you've got in filtering the models themselves and filtering the columns, the attribute columns that appear here. And if you clear those fields out, then you'll get all the attribute fields as well as all the models that appear. And if you've got a lot of attributes, you can also paginate between the pages of attribute columns that you have. The last tab we have in the dataset is the model product category mappings. So this is when we assign our products to the models that the manufacturer creates. So we were talking about the Epson printers as well as the iPhones here. This is when we would then assign our products. So for printers, if we're selling ink cartridges, then we would need to assign our ink cartridges to those models, and we also need to place them into a category, since models could have many different categories of products. So in this case, we have inkjet cartridges that may be assigned to printers, but we also may have a cables category that we want to assign products to for these printers. So in our categories, we need to set up and define the categories that we want to assign products to for each model. For example, if we're dealing with motorcycle models, then you can see that you may break the products that can be assigned to those motorcycle models into different segments. So batteries, bearings, braking, oil, maintenance, and tires. And then from there, you can see a list of products that are applicable to those models and can be purchased. So that's what this model product category mappings is to do. Continue on with our printers example. If we go back into the products tab, if we've previously imported our printer ink cartridge products into the dataset, and now if we do a filter on that and we want to find all products that are associated with the 220XL that can be used within our Epson printer model, then we can go through here and we can find the unique identifier of those products. The tab will already show the list of models that we've previously set up within the dataset. We just need to assign both the key category ID and the key product ID. For this workforce printer, if we put in the unique identifier of that product, then you could see over here that it will find the corresponding name and code of that product. And same for the category. We know that there is a category called ink cart. So if we assign that there, then you can see that it is now assigned ink cartridges category to this model. So when somebody looks up the Epson Workforce WF2630 printer, then they will see a category called ink cartridges, and underneath that category for that model, then they will see now all these 4 different ink cartridges that are applicable to that model. So that gives them options to choose from which ink cartridge should they use to buy to install in their printer. Every time you assign a product to a model, you can specify how much quantity of that product needs to go into that model. For this printer, it may actually have 4 slots for the ink cartridges that can be used, or it only may have 1. If you're assigning tires to a motorcycle, then you'd set the quantity as 4, since 4 tires need to be set against a motorcycle. Once we've got that set, if you want to, you can also replicate the row. So we just click the insert button, and that would duplicate the row, and then we can set the next value without having to key all the other fields. So we go back here, we'd find the next printer cartridge that is available, get its key product ID, and then we would update the value there. And once that's updated, the values will update in the created and last modified date, and we need to also set the quantity. And then we've also got the is active and is updated to denote if these records are updated. And the notes field allows us to put any more information about these particular products that are assigned to these models for the given categories. Also within here, you can then filter out the models that you want to assign your products to. So we may only care about models that have Epson in the model name, since we're managing make model data for the Epson printers. So we could choose that. And then it will filter to only show the Epson models that we need to assign our products to. You can also lock the make model columns, so that way if you need to scroll across, the main model columns will stay there, where you can still scroll to the other fields that are available for the product data being assigned. If you want to remove a product and category being assigned to a model, just select the row on the left hand side. You can do also shift select and then click the delete rows options, and that will remove those products from those models. And the same is true also in the model attribute values tab, the models tab, and the makers tab. If you have a lot of models, you can use the paginators to go to the next page of records, and you can choose how many pages of model data you want to display in one page. If the number gets higher, then it will take longer for the records to load. If it's smaller, it will take less time, but not be able to see as much data. So once all this make model data has been set up within the dataset, we now need to configure a generic adapter to be able to export the data out to the corresponding platforms. Back within the connectors, adapters, and messages tab, we need to set up a generic adapter that we're going to use to export the data out of the dataset and push it across to the relevant e-commerce platforms, or even to another dataset. So we'll get our downtown office supplies example here. So if we click on the settings button, then within the dataset, we can choose either to load the Squiz.com connected dataset preset, which will automatically set up all the data exports we need, but do note it will also overwrite any data that's in non-make model datasets. Typically, you'd only use this on a new generic adapter. What that preset will do is it will configure the makers, the maker models, the maker model mappings, and maker model attributes data. So if we go into that, the data for the makers within the datasets SQLite database is set, and it needs to be set to is active to only get the active maker data. In the fields, we can use all the same names of the fields and just copy them across. Make sure for the dates that you cast them as text, otherwise errors will occur. And the same for the models, it's very similar. So the table in the datasets SQLite database is called maker model. We also want to make sure we only get active make model records out of that. And then it's a similar thing where all the names of the fields are very similar to the standard field names in the generic adapters data export. We just need to make sure we also correctly handle the dates. The maker model attributes contains all the model attribute data, and that's got a table called maker model attribute value, and then that has all the same column names as well. The maker model mappings is the table that stores the relationships between products, categories, and models. So that's where that data comes from, and then we can set the fields there. You don't need to set the key download ID or key labor ID fields, they can be left out. The make model mapping attributes is currently not supported yet, both in the dataset, so that can be left empty, and we don't need to set that. Once all this maker model related data exports have been configured, then we can then run an export and run the makers export, the list of makers into the corresponding e-commerce platforms, as well as then run the maker models, which we export out the model data and attributes assigned to each model. Then finally, we need to run the maker model mappings export, which will get all the products and categories assigned to models and export that data. So they need to be run in that order, and to ensure that the data correctly imports into the Squiz.com and Totex platforms. Once that's available, then users can then use the make model searches to find the products that they are looking for. Now, make model data can be somewhat complex to set up, or where there are lots of manufacturers and lots of models, then you may wish to get that data from external data sources rather than keying it from scratch, and then it would be best to set up a generic adapter. It can read in the data from CSV files, XML files, or from a given web service, and then import them into a dataset where you can then refine them further, or import all the list of make models, use the model product category mappings to create those mappings with your own products. That is a way to reduce the amount of data work that is required. You may wish to also pass make model data between datasets as well, so that is entirely possible. The only real difference is within the export routines schedule window. Once you've selected that export, you would then import it into another connected dataset as opposed to anywhere else, and that's true for any adapter that's configured to retrieve make model data, that you can then use these exports to import the data into a dataset. So this adds support for make model data within the datasets feature of the Squiz.com connector. Within the connector's 1.24 release, under the datasets tab, when opening a dataset, if you haven't already noticed, that the tabs bar of the datasets window has now been updated and improved to now be a full ribbon bar. So this contains all the same tabs that we had in the previous releases of the connector. It's just that now they get some nice icons. And we've also grouped those different types of data into different sections. So we've grouped the product, sale units, and attributes data into the core group. So this is data that is around the core product data that is needed in order to export and display products within the corresponding e-commerce platforms. So products contains your list of products, also known as items or inventory, also known as SKUs in some systems as well. That's what products does. Sale units, naturally, that's where we get to define how our product quantities are bundled together for products. Attributes allows us to set additional information about products, basically create unlimited amount of fields where we can set any information very specific to the types of products we sell. The navigation and searching contains all the data that is around being able to find products. So that's either using category tree data structures where users know the categories of products that they can then drill down into to find the specific product they're looking for. Flags is another way to find products based on identifiers that appear against products, such as being on special or being new or discontinued. Locations also allows products to be found in specific locations that may be local to them. A make model, which we talked about previously, is using the make model searching to be able to find products that are components of models. And alternate codes allows people to find products based on knowing a different code for a product that may be industry based or widely known. The grouping linking section is all about data structures that enable products to be grouped together or linked to each other. So combinations is about having a collection of similar products that may be just different based on color or size or field combinations that users may need to select from, or there could be any fields that you want to create. Item relations is all about linking one product to another. And when a person sees one product, then they see a list of other products that product may be associated to. Kit components is very similar, where you can bundle products together to make up a single kit. And finally, the files section contains the images of products that you may want to set up that allows people to identify products that they're looking at, as well as attachments to see any additional data that they may need to download for that product, such as warranties, specification sheets, or any other additional information. And if you need to find more information about how to use datasets, you can always click on the datasets docs help link. That will take you to the Docs Center and to specifically the page that explains all the details on how datasets work. So this ribbon bar should make it easier to use and switch between the different areas of the dataset. In the Connectors 1.24 release, we've modified the datasets feature to be able to view the list of products within its own window. So I'm here in an existing dataset. We've already imported a number of different products, which contains over 8,000 products. When I'm working with other data, such as the make model data, and I'm needing to assign these products to say models, I may wish to have the product data appear in its own window and use a side-by-side comparison that makes it easier than copy and paste data. So within the products ribbon menu, if you click on the arrow, you'll now see that there is an option to open products in new window. Once we've clicked on that, that will open up a new window where the same product information can be displayed and moved around separate from the rest of the datasets window. We could create multiple product windows, just as I've done here, and then we can use this in order to copy and paste data between different sections or different parts of the product catalog. Now this is particularly useful for not just copying data from one set of products to another, but it can be also used if we get the datasets window. When I want to do a lookup on the key product IDs and then I need to use them, I'm linking them to other structures. So if I'm in the item relation section and I need to link one product to another, I can then link one product to the other in the other window just by copying and paste the data across. So that's one example of how you can use multiple windows. Now, normally you'd be using a bigger screen to do this, so you'd be able to see more of the columns that are available here, but this is a very useful feature when you're needing to assign products to other tertiary data. By having these two windows side by side makes it easier to look up and compare data on both sides, as well as copy and paste between the different places within the dataset. And the same is also for make models. You can also open the models in its own window as well. So that shows the same make model data that we had before. And we also may want to use that, such as if we're assigning models to different products. We could then copy the model data over here, and then when we're setting up those mappings, then we can just paste them over on the other side without having flicked between the different tabs again. So this can make it easier as well to set up this data. Within the Connectors 1.24 release, we've added the new capability to integrate with the PARtsDB online platform, and PARtsDB manage make model data across the automotive industry. So if we take an example, we may have a website that has the make model search forms, uses the make model data structures to allow customers to be able to find products based on knowing the vehicles that they need to purchase products for. I'll take an example here. They would then find the model of their vehicle that they may need a new part for. So let's just choose a Toyota Camrys, for example. From there, they'll get a selection of models that matches their car that they order a part for. And then going into there, then they can see the details of that model, as well as all the possibilities for products that they can then choose from to order with. So PARtsDB takes care of being able to manage the list of manufacturers of automotive vehicles, as well as all the models that belong to each manufacturer and all the years those automotive models have been manufactured for, as well as containing the attributes of each model vehicle. Now, PARtsDB allow all businesses to be able to assign their products or match their products with the corresponding components those models create. So a company selling air filters or oil filters can then assign their products to PARtsDB's database of air filter products, and then that will then automatically populate against all the makes and models that particular air filter is available to be purchased from. So in effect, PARtsDB cut out all the hard work of managing the entire list of make model data across the automotive industry and making sure that keeps up to date when new vehicles are getting released into the market from the manufacturers. Taking that all into account, what we've done in the connector is to hook into the make model data to be able to pull that down and then export it across to the corresponding platforms. Now, to see how this works, we've created a new piece of software called the PARtsDB add-on connector, and that will then talk to the PARtsDB platform, and then it'll look to pull down the make model data through PARtsDB's system through its APIs version 1.1, and it'll pull that make model data in, and then it will store it in a SQLite database file. And in the process of pulling that data in, it will then translate that data so that way it can be easily read by this quiz.com connector software. So the make model data gets stored in a separate SQLite database file. Then within the connector, we use a generic adapter to then pull the make model data in there. It will then translate that make model data into the e-commerce standards documents format, which we use in order to then send that out to the different e-commerce systems, the Squiz.com and Todex systems, as well as it can be also sent across into the dataset. And we talked about how we can now manage make model data within datasets earlier in this video. We can further add to any kind of make model data that is coming back. So with all these connections in place, we can use schedulers to ensure that make model data that is managed within PARtsDB for our business and associating all of our products to their wide and increasingly growing make model database. And we can pull all that data all the way through to the corresponding e-commerce platforms where our customers can then use that data to perform the make model searches to find the products that they need to purchase on those online platforms to make the sales. So the first thing we need to do is to install the PARtsDB add-on connector. This is a web service that runs on its own. It is separate from the connector software, and it runs in the background as a Windows-based service that is always running, so that way the connector can then talk to it when it needs to in order to then get the data to pull down the make model data and translate it as it goes. So to do that, we first need to go to the squiz.com/docs/connector URL in a web browser, and then we need to scroll down and go to the section called add-on connectors and go to the PARtsDB add-on connector. From within that page, if you go down then to the installation and setup steps, this can then tells you all the requirements to run the PARtsDB add-on connector software. Now there are a few prerequisites that we need to have on our computer that we're installing the add-on connector on. Firstly, it must be a Microsoft Windows-based operating system, version 7 or higher, or Windows 2012 or higher. The Windows user install with must have privileges to install Windows services. Needs to be have installed .NET version 4.61 or higher. And it's also a computer with at least 2 gigabytes of available space, but ideally you would want 10 times that amount of space to ensure that your computer doesn't run out of storage. We want at least 1 gigabyte of RAM, but ideally you'd want a computer with at least 8 or 16 gigabytes of RAM in this day and age for it to run very well. And we need to make sure that the Squiz.com connector is already installed, and that's the host service as well as the application. And the computer also needs to have access to the internet, since it's going to be used to retrieve the make model data from the parts database. So with all those prerequisites done, we now click on the download link to download the file, and we run it. That will open the installer, so we just click on the next buttons. By default, it's going to be installed under C drive. Under the program files is the 32-bit directories in that location that is put in there, so it's typically recommended just to keep that location unless there's a specific reason not to install it there. And we click the next button. So that will go through and install our PARtsDB add-on connector. If Windows brings up any user access control permissions, just accept them. So that means that the PARtsDB add-on connector is now installed on our computer. Now once it is installed, we recommend that you modify some settings of that service to make sure that it always restarts itself in case some kind of error happens. So if we just type in services, Windows will bring up the services list, and we'll see that now there is a service called Squiz.com PARtsDB add-on connector. So that's the service that has been installed and that is running in the background of Windows. And if we right click on that and go into properties, and clicking on the recovery tab, it's recommended to change these settings to restart the service. So that means if any kind of critical failure happens that service has to stop itself, then it'll immediately restart itself, and that makes sure it's always run and always running in the background, and that makes sure that connector can always retrieve the make model data when it needs to do that job. So we'll click on the apply button. That now sets up the Windows service. And you'll also notice that the PARtsDB, there's also a link to run that Windows service as a standalone, but we need to stop the PARtsDB add-on connector service if we're going to run that as its own console, otherwise it will report errors. But that is an alternative to as opposed to running this in the background. Now once the Parts database add-on connector has been installed, if we click on the link here, that will then open up the add-on connector's user interface, where we can configure the add-on connector to talk with the PARtsDB platform. Now, if the page doesn't display, you may need to set up Windows firewall exceptions to allow this web service to run in the background on port 8091. By default, that's the port that it's configured to run on. And if you do have other software that is running on that port, then you may need to modify the underlying SQLite database manually in order to change that value, or stop the other service that is running on that port until we then configure this add-on connector to run on a separate port. So the username and password to log into the add-on connector's user interface is user and change it. If we type that in, then we should be able to successfully log in. Now from this interface is where we can configure the different aspects of both the web service itself. So by default it runs on the local host, and it's recommended that the PARtsDB add-on connector is installed on the same computer as the connector software to reduce the amount of problems that could occur otherwise going over networks or going over the internet. So we recommend keeping that as is. Now this is where you can change the port number if you've got other pieces of software running on the port 8091. So this is when, if you wanted to change that to 92, you'd put it there. Do note that if you change the port number and save these settings, that you'll need to update your URL in order to be able to access this again, and you'll need to restart the PARtsDB add-on web service so it's listing on the new port number. Now, as you saw before, we logged in as the user called user, and with the password change it. So this is where we recommend you change these default values. So instead of user, you might have a specific name of a user that you want to type in, and change the password to stop other people being able to access this web service. And they've also got options whether or not when the requester to get the make model data, if we want to use authentication using this username and password credentials, we would recommend to set that to yes. To make sure not any piece of software can access this web service without going through at least knowing the username and passwords. And the log date format can also be set so that if you're running the PARtsDB add-on connector as its own console, the format of the dates will be based on this, and this is based on the .NET date formatting conventions. There is a link to explain on how you can set up the log date in a different format if you need to, but typically you wouldn't need to change this setting. Now that's it for the web service running itself, but the PARtsDB setting to actually talk to the PARtsDB system need to be configured here. So we've already by default got the URL to PARtsDB's API. This shouldn't need to change unless they update their version of their API, but we recommend to leave it as is. Now in the brand ID field, every business that is set up on PARtsDB will get its own unique brand ID. So we need to get that credentials from PARtsDB, and we recommend you talk to them. And that is also for the user and password. So we're going to need those three credentials that will use the account set up with PARtsDB in order to access their system. So for now, we'll just use some dummy data here just to show you what this would look like, and they would have a password. Now all the rest of the URLs is set up to obtain the different types of data from PARtsDB's system. So the URL to retrieve the list of makers or manufacturers is using this, and anything with the curly brackets is our data hooks. So the value set in the brand ID field here will then be placed into here, so we don't need to set that up manually for each of these URLs. And there are some other optional parameters we can put into those URLs. We would typically recommend not changing these URLs unless there's a good reason for you wanting to do that. So they're already set to be able to get the list of makes. There's a URL to get the list of models. Now note that in PARtsDB they called models vehicles, whereas in the standards we call them models. So that's why there's a difference there. But basically the add-on connector will get their list of makers, and then from there it will try to retrieve the list of vehicle models from PARtsDB, and then it'll go a step further. It will break down each vehicle model from a range of years into specific years themselves. After we've done that, the PARtsDB API can then be used to obtain the list of products which are assigned to each make, model, vehicle stored in PARtsDB. So that's what that URL will do there. Now optionally you can also manage category tree data or categories within PARtsDB, so that's where that URL request gets made with that URL, and we can see that there is some parameters here to be able to paginate pages of data PARtsDB allows data to be retrieved in. And same for the last request, is retrieving the products that are assigned to each category. So by default, we don't recommend changing any of those URL settings without at least first looking at PARtsDB API's documentation to work out what the options are available there. Now, once we've made all of our settings here, we just click the save button, and then that will apply those changes. And if we've changed the username and password or any of these credentials, we may need to log in before we can then access this again. So this is purely only for setting up the credentials and the configurations of how the add-on connector works. But after that is been set up, then we can largely leave this screen alone. So that now sets up the relationships between the PARtsDB add-on connector and PARtsDB, and the SQLite database file will be automatically created. And by default, that will be located in the C drive under Program Data, under squiz.com, under the PARtsDB web service. That's where we can find the app.db3, that is the SQLite file that will store the make model data that is being retrieved from PARtsDB that the connector then needs to access. Back within the connector software, we would then typically set up a generic adapter to be able to then retrieve the data from that SQLite database file. So we might call this PARtsDB make model data. So with our new generic adapter created here, if we go into the settings, under the Load Adapter Presets dropdown, there is now the squiz.com PARtsDB add-on connector preset. So we can now select and click the Load button. Within the preset adapters data hook settings, we can see that there's one setting here where we need to configure the location to the PARtsDB add-on connector's SQLite database. It's already pre-configured there, but that may not be exactly right. If you install the add-on connectors into a different drive or location, in this case it matches up with where we've stuck the location, but we can change this setting at any time in the future. So we'll click the Save Settings button. Now what that will do is that will configure a data source here that will contain that path we just talked about. So if we had to change that file path to the SQLite database in the future, we would then be able to do it from here. But the main thing it does is within the Data Exports tab, for both the makers, maker models, maker model mappings, maker model attributes, as well as categories and category products, it will set up each of those data exports, and that will contain the make model data and category data that's coming from the PARtsDB platform. So as we can see here, it's fairly straightforward in how these are all configured. The names of the fields are identical to the way that the standards have been set up, so you shouldn't have to change any of these values here unless you specifically want to override or put in some additional configurations on how the data is getting exported out. So an example of that would be maybe if all the manufacturers' names were all coming up as a title case, you may want to convert them all to uppercase. Then we could use the upper function that is available in SQLite to convert all the names of the manufacturers to be all capitalized. That is just one example of how you can then alter the data after it's come out of the PARtsDB system. And the same goes for the make models. We could also make adjustments like that, and same for the mappings. We could change some of that information if we wanted to there as well. So that is all possible there, and the same goes for the categories that are coming out of that has been pre-configured. And for example here, there are not any fields in PARtsDB that contains descriptions of categories, so we may want to add additional information about that here, or we might want to use a data set and leave these inactive and use a data set to put in information that is missing. Now right now, if we try to test these out to make sure that we can get some data, You'll notice that there is no data that is actually stored in the SQLite database yet, because we haven't asked the add-on connector to talk to the PARtsDB to try to obtain the make model data. So to do that, we need to set up some routines that will then cause the connector application to tell the PARtsDB add-on connector to retrieve the make model data from PARtsDB stored in the SQLite database. So to do that, for our adapter, we need to set up some routines. Back within the settings window, if we click on the data routines, we need to set up some get HTTP request routines. So we click the create routine. The steps in the documentation explain to us how we need to set up these routines. So we want to call one routine cache PARtsDB makers, since we need to get the list of manufacturers out of PARtsDB. So that's where we're going to call it that routine. Click the save button. And if we look here, we then need to set up the URL based on this setting. Now, because this is going to be making a local connection, it doesn't necessarily need to be secured, so the protocol is just HTTP. But if you were having the PARtsDB add-on connector installed on another computer outside of a safe network, or even across the internet, then you would want to start looking at trying to secure the connection between the connector and the PARtsDB add-on connector. So that's when you would change the protocol there. So we'll set the URL based on what's configured there, and note that you may need to change the port number if you had previously changed that. And we will set the timeout at 60 seconds, since it should take far less than that to get the list of manufacturers from PARtsDB, but we put some padding for slow connections there. And we want to put in some validation to make sure when we know if the routine runs successfully or not from the PARtsDB. So if it hasn't run successfully, then we know that there's an error with the configurations of the PARtsDB add-on connector. And we can also look at that by looking at its console, by running the add-on connector as its own console application, which will tell us those errors precisely. Now, if you had set the data request requires authentication back within the add-on connector, then that means that we need to configure our request routine to pass in the username and password credentials and to authenticate first before it can request that the make data is retrieved. So to do that, we use the data field. So we need to click on the add data field. In the source field, we need to type in the word authorization, and then in the destination field, we need to type in the word basic. Capitalization is important on the word basic. And if we close this window for a second, go back into the tools menu and the base64 text encoder decoder, this is where we put in the user, whatever our username was, as well as the password and what we set. Originally it was set to change it, but we would set the most up-to-date value. Click the encode button, copy that value out, back within the settings in the routines, under the data fields, put a space after the word basic and copy that value in there. So that's our basic authorization that we use to allow the connector to talk onto the PARtsDB add-on connector to be able to make the request it needs to. So with those settings now set up, we can continue on. We need to create additional routines. We need to create a routine to be able to cache the models. We'll update that routine name. We needed to create another routine that gets the mappings of products and categories to each of the models. So that's where we'd create that routine. And if we wanted to get the category data, then we'd need to run the routine that enables that to be cached or stored or retrieved from the PARtsDB. So we'd create a routine for that. And for each of those routines, we need to change each of the URLs and the times of how long those are allowed to run for, since they're going to be retrieving data from the parts database, and some of these will take longer to run. So typically most of these allow for 1200 seconds, 20 minutes for each of those routines to execute. Once they've been set up against the generic adapter, we should have these 4 routines that are going to make requests to our PARtsDB add-on connector. Now we can run each of those by, if we go back into the exports routines, they will now come up in the list there, and we can either run them once off, or we can set these routines to run on a scheduled basis. And that is typically the best approach because we want full automation. So we would normally set this up to most likely run in the early mornings because we don't need to run in the middle of the day, taking out any resources. If you want to receive a report on if these are successfully run, then you'll click the yes, or only if it fails, you've got that option as well. You can choose how often it runs. So by default, this is going to set to run once a day. That should be sufficient. But if you think that's overkill, you might choose to run it once every 7 days, or may have to run multiple times a day if you're updating your products mappings to the make model data in PARtsDB. But typically would recommend running it in off-peak times at a frequency that's not too often, since it would be putting more load on PARtsDB's system. So once a day may be a nice number, or once a week may be sufficient. So click on the add button and we'd set up schedules for each of these, and would make sure each of these run to allow enough space for the next routine to fully complete. So the makers may be taking up to 120 seconds, but we might give it an extra 10 minutes between when the next run runs. We need to make sure that these run in the correct order. So we want the makers to run first, then we want the make models to run, so they'll get all the model data. So that depends on getting the makers first. So that runs 10 minutes later. Now that may take 20 minutes to complete. So then the maker model mappings will then have that routine called the caching to happen. So we would give that 20 minutes to complete. So that's 3:45 a.m. Then that would run. And then the next one is the categories that can then run 20 minutes after that. So then we're getting into 4:05 a.m. in the morning. Based on these settings, it's going to run once a week. The connector is going to make a request to the Addon PARtsDB add-on connector to call to get the make model data from PARtsDB and store them in the SQLite database file. That's the caching mechanism that we talk about. So that's the routines that the connector we've now set up. Now the last part is to get the make model data out of the SQLite database files. So we've already set up the data exports to be able to do that, but we need to also schedule them to run so that way that data can then be forwarded on to any of the e-commerce platforms or the datasets feature in its own right. So to do that, we would then go into the data exports, and then we would select each of the exports that we want to run. Following on, we could run that once off to export that out to the corresponding platforms, or we could have it run on a scheduled basis. So if this routine is finishing, if it's starting at 4:05 in the morning, then we might give it 20 minutes to complete. So we'll just keep going on. It will then export the list of make data out. And we want a full transfer mode to get all that make model data so it updates with the corresponding platform. So we might import that into Squiz at 4:25 a.m. Then after that, once again, that needs to be run in the same order where we get the makes, the make models, then the mappings out. So then we'll schedule that. Now this should take a lot quicker. So we should only need to allow a couple of half a minute or so for that to run, but we'll give it 5 minutes just to be nice. So then that runs. After the make models export has been run, we first need to export the product data out because maker model mappings depends on products and category data having been set up. So we'll click to add that to the schedule first. So that's going to run. The make models may take up to 5 minutes. So let's to export across to the platforms. So let's give it 10 minutes just in case. And the mappings also depend on the categories being imported into those e-commerce platforms first, because the category data products need to be assigned to categories for each of the models. So we'd have that run next. And typically it'd only take less than 5 minutes for product data update, but we'll give it 10 minutes just to be on the safe side. Then after that is all done, then we can run the maker model mappings. Categories should only take under a minute or so, but we'll give that 10 minutes just to be on the safe side as well. And there we have it. We now have our caching routines to be able to request the PARtsDB add-on connector to talk to PARtsDB and pull down the makes data, the make model data, the make model mappings data, which is the mappings between products, categories, and models, and the category data. Then once that data is all being stored in the SQLite database, then we're going to run each of these exports to export the make model data to the corresponding e-commerce platform, which has been set up there. And we may want to export it to multiple platforms, so we'd continue just how we were doing here and just change the e-commerce platform we're sending it to. Or we could have it also instead get sent across to a connector data set where the data can be managed and manually then configured to export to the e-commerce platforms from that data set instead. So that gives you a full rundown on how to configure the new PARtsDB add-on connector software to talk to PARtsDB, to pull down the make model data, how the connector initiates the request for that to happen using the generic adapter's HTTP GET request routine to make that possible. And then once the data is in the SQLite database, we use the generic adapter to pull the data from the SQLite database and then push that data across into either the Squiz.com platform, Todex platform, or a dataset. And if it's in a dataset, then we can use a generic adapter then to push that across at a later date as well. So it's a somewhat complex mechanism, but there's a lot of customization that we can then add to those mechanisms once the data is getting passed across. And it also makes sure that when the make model data is on the associated platforms, that it can load up very quickly, allowing customers to instantly find the make model data they need for their vehicles in order to then buy products across the automotive industry. If we get this all right All this can happen seamlessly without any user intervention once it has all been configured up, where the make model data flows all the way through without any humans requiring to manually push that data around. It can all be done through the scheduler that is configured within the Squiz.com connector software. Now, naturally, if you've got any more questions about this, we would recommend going to the Squiz.com platform. If you haven't already signed up, sign up and then go into the profile page of the Squiz.com organization, where there is the Squiz.com connector feed, where you can ask any questions that you're having when trying to set up and configure the connector software to be able to work with PARtsDB. Within the connector's 1.24 release, we've added the ability for it to integrate with the Readysell Enterprise Resource Planning System. Readysell provide a system that enables a business to manage all their business data and processes in their enterprise resource planning system, including sales, purchasing, inventory management, multi-location warehousing, among many other capabilities that you can see on its website. The Squiz.com connector is able to integrate into the Readysell system using a generic adapter preset that talks to Readysell's underlying API, where it can then pull out all the product inventory, sales, customer data required for a business to sell on the Squiz.com Todex platforms. Now, to hook the connector up to the Readysell system, if we go into the connector application, first we would set up a generic adapter and we would give it a name. So in our example, let's just call this Readysell. Once that generic adapter has been created, click on the settings button. Within the generic adapter settings window, from the list of presets, the Readysell preset has been added to the list that we can select. And then we click on the load button. For a new adapter, we can safely say yes to load this preset in. And within the adapter preset data hook settings window, there are a couple of settings that we have when we initially configure it to talk to Readysell. If we're setting up category trees, or if we already have multiple category trees, we may want to have a unique identifier of our category, so we can put in a prefix setting. You can safely leave this empty unless you already have category tree data. In that case, this could be a Readysell category tree, so then we could put in some kind of prefix like that. The more important setting is the URL for the generic adapter to be able to talk to Readysell's underlying application programming interface. So we need to set that up correctly. It's best to contact Readysell to find the correct website domain or IP address that enables the generic adapter to talk in order to push and pull data from Readysell's system. Also, we need to get the username and password for the Readysell system, and we need to put them in a base64 encoded form. So talking to Readysell, you'll be able to get the IP address and set up a username and password to access their API to push and pull the data. So once we've got those username and password credentials, we'd go into the connector, go into the base64 text encoder decoder, and for our API credentials, we'd get the username. So it might be some kind of Readysell API user, and that would naturally have some kind of password, and click the encode button to get the encoded form of that username and password combination. Copying that data back within this setting, we would then paste that encoded value into there, and then we've now got our credentials set up and ready to go. So click on the Save Settings button. That'll take a little bit of time just to load up all the data exports and imports for the generic adapter configured for Readysell. So once that's done, we click the OK button, and we can see that there are now two data sources that have been set up. One to import or read data directly from Readysell's web service in the e-commerce standards documents format. And the other one is if we want to more customize the data going in and out of Readysell. So we've got also this JSON-based web service that provides further customization abilities. After deploying that, we can see all the data exports and imports that are available with this preset by clicking on the Generate Adapter Documentation button. And we'll save that file. You can call it whatever you want. So I've just called it the Readysell adapter. That will contain a web page file where we can see how this generic adapter has been configured initially out of the box with the preset. So for Readysell, the generic adapter is able to retrieve category data, and all the different exports that are highlighted denote the ones that have pre-configured. So we can get out the customer account contracts. We can get out customer account addresses. We can perform real-time querying on the different aspects of Readysell's system. So that includes invoice searching, credit lookups, back orders, payments, quotes, and sales order, real-time inquiries. We can also get the status of customer accounts and the customer accounts list themselves. We can get the location, so that's warehouse locations, as well as the product stock availability on each of those locations. We can get the payment types, the price levels that it can be set up in Readysell, the product alternate codes if we assign different codes to our products. We can get all the pricing unique to customers from Readysell, so that's using their advanced pricing data structures. We can get product images from Readysell system, as well as the product price level pricing and the quantity break price level pricing as well. We can also get product stock quantities, products themselves, so that's the stock availability of products, as well as the list of sales reps, sell units, which are needed to be able to sell in the Squiz platform, as well as the tax codes that enable us to price the taxes into our products. So that highlights you all the supported data that we can retrieve from the Readysell system. On the opposite side, we have the sales orders data import, so that allows us to push sales orders back into Readysell using this preset. Now you may know that not all of these data exports are highlighted. In the future, you may wish to further configure some of these data exports or data imports based on how you've set up your Readysell system, or you might want to then use data sets or use other data sources to retain other data that is not supported by the preset. In the documentation, we can also then go deeper in to see how each of the data exports has been configured, which just reflects the settings actually within the generic adapter itself. So for the most part, many fields have been mapped from Readysell. So that will reduce the amount of work that needs to be required in order to get this integration up and running. We're basically set up and we can already start exporting data out of Readysell now with our generic adapter configured. But you may wish to go into each of these exports and further refine them if it's necessary. For example, you might want to change stock availability based on customized calculations that you have for your specific business. For example, you might have a rule that says if the stock quantity in Readysell is, say, less than 5, then we'll always show that we have 5 in stock even if we don't. We can then alter those calculations here, or we could have a thing that's saying that whatever stock we have, minus it by 10, so that way anybody online, the chances of them not being able to order something in stock is reduced. So that is just one of many examples of how you can further refine the generic adapter that we've got here set up with Readysell. So with that all done, all we need to do then is then set up the data exports to then export our data out from Readysell and into the corresponding e-commerce platforms or the data sets themselves. So if we were going to export data from Readysell, we would just select the export products for the Readysell adapter, choose the system that we want to go into, such as the Squiz.com platform, and set the data transfer to full, and then we can then run that data export and export our products out, or we can schedule them to run on a regular basis, such as each day, and typically it's better to run them in off-peak times when systems aren't getting utilized at the highest levels. It is important when you're configuring the adapter for Readysell that you set up and configure exports to be scheduled in the right order, and we can find that out by going to the Squiz.com connectors documentation. Under the data export routine scheduling page, it tells you the dependencies that data exports have on other data to run first, which is shown in this diagram here. So we need to run the price levels, for example, has no dependencies, nor the sell units. We would schedule them first before we run the products export. Products export needs to be run before all these other exports run, because they are all dependent on products previously being imported into the Squiz.com as well as the datasets features. Here's some examples where I set up the data to export out from Readysell. So we're going to export some tax codes, sell units, price levels, sales reps, products, customer accounts, customer account addresses, and so on and so forth. And we will continue to schedule them out and give enough time between those exports to run, so that the way they can fully import into the e-commerce platforms before the next export runs. So with that all done, our product data and all of our data coming from Readysell can then be synchronized with those systems. And then the connector can receive orders back from those platforms. If they are imported against the Readysell adapter, it can then forward those orders across to Readysell using the sales orders data import that's already been configured with the generic adapter. So it's quick and easy as that in order to configure the connector application to integrate with the Readysell system using a generic adapter and the Readysell preset that has already been pre-configured, enabling businesses to get selling on the Squiz.com and Todex platforms faster and seamlessly getting sales orders back into their Readysell system with minimal effort required. Within the Connectors 1.24 release, we've added new capabilities into the Connectors JSON XML CSV query browser, as well as the associated JSON XML CSV web service file data source type that is assigned to the generic adapter. So if we open up the query browser, I pre-configured this query browser to read some JSON data that is stored within this raw tab here. And in here we have example product data where we have a list of products and each of them has some product names. So in these product names we have some t-shirts, and They're of different sizes, so we have an extra small, small, medium, and large, and we can see that there is some different spelling of the word grey. So within this release, we've modified the replace function, which we can typically use to find a piece of text and replace it with another. So in our field function here, we use the replace word, and maybe we want to find the word grey with an A in it, change it to the word with the E in it. Normally that's how we'd use the replace function here, and we can see now the grey word has got the A being replaced with the E, but we can see that we've got some other misspellings here for the color grey. So normally we would have to nest that replace function with another replace function, try to find the different spelling again. So in this case, anything with grey is now going to change into grey as well. So we make that change, and then we can see that we've got the spelling has been corrected. The new capability that we've added to the replace function here is to be able to use regular expressions to be able to replace the values that we need to. Now, regular expressions is a somewhat complex affair, and many people struggle, including myself, because it is a very powerful capability of a programming language, but can be quite complex to understand and to work out how to use it effectively. What it can do is reduce the amount of nesting that we need to do in the replace function when we need to fix up data or manipulate data in different ways. So if we click on the JSON XML CSV field functions documentation link that we've got within the query browser, and we go down to the replace function, there is now an additional argument that can be added to that function where we can put in the value regex, which is short for regular expression. This replace method can either be set to a literal value or ignored, like how we have here, or we can put in an extra parameter and call it regex. So when we do that, we can take this same example, which is trying to find the different words of grey, and we can instead use a single replace function to change this misspelling that we have. Now, in regular expressions, there's many ways to do stuff, and we are using the .NET version of regular expressions. So here's a simplified version of that field function that we have. So what this is doing is we're using a regular expression, which is the pattern is embedded here, and it's going to find any text that starts with GR and then has a character, any character, and replace that with the word grey. So if we run that again, that has been able to fix up the spellings of the words that have the A as well as the I within the word. But notice that it hasn't fixed up this spelling for the word that has the double letters in it. So that is still coming out of here. That's because our pattern is expecting only one character between the R and the Y. We can up the ante on the complexity of the pattern that we're matching. So here's an example where it's going to find any text starting with GR, and this is some special regular expression here where it's going to find one or more of those characters that are before the Y character. And when that occurs, it's going to replace that word with the grey. So it's going to match on these different misspellings of the word grey, as well as when there are many letters between the R and the Y. So we run that again, and we can see in our second example here that it's been able to fix up the spelling of the word grey, whereas the first version of the regular expression did not. So that is another way we can use regular expressions to fix up spelling without having to nest multiple replaces. Now you can also do this a separate way. Regular expressions, you can also use this where we're trying to target specific letters in the word grey. So we only want to target letters that have the word E, A, or I in the word grey, and that would be fairly similar, but we can see that it's missed the double A, but we could have the double A here, and that has also fixed up that spelling. So there's 3 different approaches in which you can fix up spelling within data. In this case, we're looking at product data, but it could be any data that's been exported from any web service or file through the generic adapter, and using through this query browser to do this. Now, I'm not going to go into a lot of details of regular expressions because you could spend a whole short course learning about them. We can do some very powerful finding text and replacing text using some very smart and sophisticated rules that are very short, as opposed to doing some very complex logic that we would otherwise have to implement. Now, the last example I'll show you here, we can target different patterns of text that appear. Now, we may want to target numbers as opposed to letters. So here's a fourth example I have here, where this is a very simple irregular expression. All it's looking for is this special /d special pattern that says any kind of digits that are found within text, we then want to replace them, and in this case we're going to place them with nothing. So we're basically going to replace the numbers. So that should remove all these numbers from the end of the text. Now if you look at that, we can see that the numbers have now disappeared. Or we could replace all those numbers with any kind of text we want. The word 1,000 there, and we can see that all the text, all those numbers have now been changed to 1,000. So this is a regular expression. It's also powerful for numbers as much as it is for letters, and I would suggest, if you are wanting to do some advanced regular expression text replaces, that to search online for some examples, and there are numerous websites where you can find good examples of how to set up regular expressions and how quick and effective they can be to fix up data or to manipulate data that is coming from different systems. While we're talking about the JSON, XML, CSV field functions, there's another function that we have added to the connector in the 1.24 release, and that is the rounding function. I'm looking at our product data here. I've now added some pricing data that we have with each of these products. So we can see that some of these prices are stored to 4 decimal places, others are only at 1. If we go back to the field function documentation, there is a new function here called round, and round allows us to round a number to a number of decimal places. So the first input is the text or the number that we need to round. The second argument is the number of places that we want to round a number to, and the third method is the way in which we want to do the rounding. So we can either round up or down. So if we go back to our example, we have our price data here. Let's take the original price in one column, and we use the rounding function within the second. So we put in the price as our first argument of the function, and we want to round to, let's just say 2 decimal places is a common occurrence. Put them in single or double quote characters because it's the literal value we're placing into this function. And then we got to choose the way we want to round. So let's just say we want to round up. We can see that it has now rounded the prices to 2 decimal places. For this number here, for example, that ends with the decimal 3369, it is rounded up to 34 because 6 is 5 or higher. And you can see the example here, that is also rounded up to 5 or higher. And for this fourth number, we can see that it was missing a decimal place and it has added a decimal place into that number. So we can change that value. We want to round to 1 decimal place, then we can change that there, and then we'll see the numbers rounded up again. Or we could even have 0 decimal places where we want what we'd call numeric integers, and we can see that value there. Now, if our rounding method was set to down as opposed to up, when we run that, we can see that the number 3453 has stayed at 0.34 cents. If this was pricing data, it has not rounded up, so that's what the down method does. Now, if by default you leave the rounding method out, then the default rounding method for this function is to round up numbers. And if you leave the decimal places off, the default rounding is to 4 decimal places for this function. Now, if the value of the first argument is not a valid number, so let's just change our data where the price is now storing an A character here, and we'll change that value in the JSON to be a string value now. What you'll see is that the rounding function will by default return a 0 value if the value trying to be rounded is not a legitimate numeric value. So that is something to be careful of, especially if you're nesting functions within functions and that may return blank values. Then by default the rounding function will return 0 values. You can also nest rounding functions within rounding functions. So in our example here, we've got illegitimate value that is going to return 0, but then we may want to round that afterwards to 2 decimal places. So you can see now we have 0.00 is a value for that price, which is incorrect data stored within it. So using the rounding function is very useful for when you're dealing with numeric data such as prices, stock availability, measurements such as widths, heights, or depths, among many data types that use numeric data to handle that. And we can also perform calculations on our rounded data before or after rounding if that's necessary as well. So let's take an example where we might get the price. We might use the calc function in order to calculate a price, and let's say we want to divide that by some kind of number. We can see here's the number that calculation would have made. It's a very long floating point number, but we can see because we put that in within the rounding function, we've now got a very elegant number which is coming up here that is a well-rounded number. So the rounding function is particularly powerful for when you have to do calculations and then you want to round those calculations afterwards. So using the rounding function as well as regular expressions for the replacing functions is yet more tools that we have in the data integration tool bag using the connector software when we're pushing and pulling data between different web services, XML, CSV, JSON data types across both files, HTTP web services, as well as within the connector's raw data that's stored within the connector itself. And that's a wrap up of the 1.24 connector release. Thanks for taking the time to listen. If you have any more questions, feel free to go to the squiz.com platform. From the profile page, clicking on the feeds, we have our squiz.com connector feed where you can ask about anything related to the connector. And feel free to like and subscribe to the squiz.com YouTube channel. Until next time, from everyone here at squiz.com, have a great day.